Hey, conceptual physics students, how about some hints for the textbook assignment that you're hopefully trying on chapter 33 and 34? So I'll just try a few of them and give you hints. I won't do the whole problem, but this might help. How about starting with number 37 on the chapter 33 assignment? There's a formula that the book has, and the formula for electric field strength, that's kind of a funny E. It's a Greek E. And so the formula is the electric field strength is how much the force is divided by every charge. So the force per unit charge. Well, the force is given in the problem, so that shouldn't be too bad. Then you just have to divide by the charge. The problem is the charge is in microcoulombs. So it says 20 microcoulombs. So what's that? But you can look on your conversion sheet and you realize that a microcoulomb is 1 times 10 to the minus 6 coulombs. So 20 microcoulombs is the same as 20 times 10 to the negative 6 coulombs. So then you should be able to divide the force by the charge on your calculator. That'll be very successful. So that's number 37. How about a little hint on number 40? I knew you'd like that. For that one, they're asking for the voltage, which is also the same as potential difference. Potential difference means the same as voltage. The formula for that is the voltage, or the potential difference, is the energy that an electron or a charge has divided by the amount of charge. So it's really the energy that every electron or every charge has to lose in a circuit. So that should be easy to apply in number 40 because they give you the energy and they give you the charge, and you simply divide those. Maybe a little hint on number 43. As you recall from chapter 32, the force formula for charges is equal to K, which is Coulomb's constant, times Q1 times Q2 divided by the D squared. Okay. In every single problem, Coulomb's constant is 9 times 10 to the 9. The charges of an electron and a proton are both the same, one positive, one negative, of 1.6 times 10 to the minus 19th coulomb. Well, because you have two charges, we are going to square that, and you can square that easily on the calculator. The distance between them in meters is 5 times 10 to the negative 11 meters, but you have to remember to square that. Now, don't forget, on your calculator, the way to get scientific notation is to use the E button, which is the second function comma. So, for instance, to type in the 9 times 10 to the 9th, you type in 9, then the second function comma, which is the same as the E, because that means times 10 to the E stands for times 10 to the, and then you can put in the 9. That'll help you a lot on that problem. How about jumping to chapter 34, where we have number 59 as one of the problems. Here we're looking for the current. Now, current formula is the charge that flows divided by the time. Don't forget, this charge right here must be measured in coulombs. So there's a hint on number 59. How about a hint also on number 62? Sure, I thought you'd like that. There are two steps for that. Remember from the reading that watts is a measure of power. And the formula for power, or one of the formulas for power, is power equals V times I. But if you solve that by algebra and we want the current, then the I is equal to the power divided by the voltage. So that's 1200 watts divided by 120 volts. And that should help you get going on question number 62. After that, you could apply Ohm's law, which from the reading you realize is R equals V divided by I. just a little bit more in the way of hint. Number 70 has a couple of parts. Part A, they tell you that there are 50 watts of power. And they tell you that there are 12 volts. Well, there's a formula that is P equals VI, and I told you about that one a moment ago. Then why can't you use that possibly as I equals power divided by voltage to find the current? And for part B, for part B, then you could use the current formula. Now you already have you already have the current, and so we want to find Q divided by T. Of course, here we're solving for Q. And so Q is equal to I times T. Well, you could multiply the current of 4.2 amps multiplied by the time of 1 second and to give you the number of coulombs. That should be 4.2 coulombs. But remember, each coulomb has 6.25 times 10 to the 18th electrons. Nice.